Good day, students. So today we are going to cover 9.6 molar volume of gases. Now, students, behind me is a table. Do not be overwhelmed by this table. Let me go through this step by step review, and you will be able to see what exactly is the molar volume of gases. Now, students, let's consider a gas. Now, let us first consider the gas oxygen, O2. Now, let us recap what you have learned as you go from left to right of this table. Now, we know that the relative molecular mass of an O2 gas is actually 32. But how do we get this? Remember, your relative molecular mass is simply the sum of your relative atomic mass. Now, oxygen, has a relative atomic mass of 16. So O2 simply is 16 times 2 gives you 32. Now, we also learned in the previous chapter this concept called molar mass. Now, unlike your relative molecular mass, in this case here, remember, your relative molecular mass has no units. Your relative molecular mass has no units, but however, your molar mass have units. The units, of a molar mass simply, is grams per mole. Because molar mass, is the mass taken up, or for that matter, the mass, a mole of the substance would have. It is numerically, just numerically the same as the relative molecular mass is also 32, but however, it has units, and the unit is grams per mole, molar mass. Now, in this case here, the number of moles, I'm going to be giving it to you. So in this context here, for this discussion, I am giving, you the number of moles of oxygen. I'm going to tell you that for our discussion, that is 1 mole of oxygen. The units of moles is sometimes written in this way, MOLS. A reminder, MOL, no S. So if you were to write this in short form, MOL, no S, Moles, only when you spell out the whole word, you have MOLS. Now, so subsequently, if we have the moles and we have the molar mass, we can actually find the mass of the gas. Now, the mass of the gas is simply found by taking the molar mass and multiplying it with the number of moles. So, in this case here, mass of the gas has a unit, it is gram. And you can see this because if you are to take 32 times 1, the mole will cancel each other out, leaving me only with grams, and in this case here, it would be 32 grams. Now, let us leave this column empty first. And now consider with me another gas. Now, let us consider your carbon dioxide, CO2. Now, your carbon dioxide gas is made up of carbon, which has a relative atomic mass of 12, and 2 oxygen, which means that it is going to add up to a sum of 44. The molar mass is numerically the same, okay, it's 44, but it's gram per mole. The number of moles, students, for the context of this discussion is going to be given. I'm giving it as 1. And the mass, okay, in this case here, will simply be the molar mass times 1. And this will be 44. Now, again, let me ask you to ignore this column for now. Consider with me now, again, okay, the same gas, carbon dioxide gas, which means that it has AR44, everything here remains the same. But now, okay, what I'm going to do is, instead of 1 mole of carbon dioxide gas, I am going to tell you I have 2 moles of carbon dioxide gas. And because there's 2 moles here, the mass of the gas right now becomes, okay, twice the mass here. It becomes 88. Now, this, okay, students, is when I will ask you to look with me to consider the volume of these gases. Now, let me tell you this, okay? I'm going to tell you the answer first before I show you the working. In this case here, the volume of gas, okay, for this oxygen is 24 dm³. For this carbon dioxide gas, okay, with 1 mole here, is also going to be 24 dm³. And for this CO2 here, okay, with 2 moles, okay, in this case here, it is going to be 48, okay, dm³. Now, students, how do I get this value? Now, in order for me, okay, to explain to you how I get this value, I need to introduce you to a law, okay? Now, this law is known as the Avogadro's law. Okay? And what does this law state? Now, this law states that 1 mole, okay, students, 1 mole, okay, you know, it's 1 mole, okay, of any gas, okay, 1 mole of any gas, okay, will occupies 24 dm³. Okay, 24 dm³. And students, if you recall, 1 dm³, okay, is actually 1000 cm³. Okay, so we can also write this as 24,000 cm³. Okay, at, okay, room temperature pressure, okay, at room temperature pressure. Okay, to be more precise, let me just write this out clearly. Okay, room temperature and pressure. Now, students, this quantity here, okay, this 24 dm³, okay, has a name. It is called molar volume. Okay, this 24 dm³, okay, it is called molar volume. Okay, and the thing is, right, for this room temperature and pressure, this room temperature, students, is going to be taken as 25 degrees Celsius. And the pressure, okay, the pressure is going to be 1 atm. Okay, so molar volume is 24 dm cubed at room temperature and pressure. Now, which means that if I were to change the temperature or to change the pressure, this volume would be different. So, in order for me, that basically means that as long as I have the same number of moles, regardless of whatever the gas is, as long as they are in the room temperature pressure, they are going to be 24 dm cubed. So, which means that the volume of gas, okay, students, is just simply going to be the number of moles times, okay, in this case here, the molar volume, and that's your 24 dm cubed. And this, okay, students, this quantity here, okay, is otherwise known as the molar volume. Okay, now, volume of a gas has a unit. Okay, the unit, yes, you guess it, is dm cubed. And now, students, with this in mind, you have understood how to calculate the volume of gas once you are given the number of moles. Now, which means that students, if I were to take this the other way around, if I were to give you the volume of gas, okay, you should also be able to give me the number of moles as well. Now, students, in order for me to do an example of how this works, let us consider a situation. Okay? Now, the situation, okay, is this. Now, you have already know that this is your 24 dm cubed. Let me just erase this off. Let us first consider this case here. My question to you is, the question is, if I have the same volume, okay, if I have the same volume, does that mean that I will have the same moles of gas? And also, would that mean that I would have the same mass of gas? This is my first question. If you like, we can pause the video here for a while to think through this question first. Okay, once you are ready, let me work this out and show you how I will answer this question. Now, in this case here, same volume of gas, which means that right now, my volume of gas is now given. Okay, it is now given. Okay, this is now given. And for the sake of this example, I'm just going to make it such that every one of this given, okay, is actually 1 dm cubed. And also, because we are just considering the different, whether the same volume of gas would give rise to the same moles of gas and the same mass of gas for different gases, I'm going to also get you, okay, to for now, not consider this case here. Okay, we are going to just consider, okay, your oxygen and carbon dioxide gas. Okay, this is going to be 32. Now, students, now this is given. I'm going to consider 1 mole dm cube of O2 gas and 1 dm cube of CO2 gas. Now they have the same volume, it's given. Now, would they have the same moles of gas? No. In this case here, the formula to use is this. The number of moles of gas is found by taking the volume, this one here, the volume of gas, and then you divide by the molar volume, which is 24 dm cube. Now, in this case here, if I were to take 1 divided by 24, 1 divided by 24, the number of moles would be the same. Allow me to press a calculator to find this out. Okay, students. Now, allow me to press the calculator now. So 1 divided by 24 after pressing the calculator and leaving my answer to 3 significant figures will be 0.0417. Okay? Now, students, in this case here, the units is mole. But before I go on, students, I want to take this chance to actually consider with me what is the units of molar volume. Students, the volume of gas is dm cube. In order for me to get the units as mole, that means that the molar volume would be dm cube per mole. So that in this way, after my manipulation, I will have mole coming up. And the dm cube cancelling each other to give me the units of mole. So in this case here, this is also 0.0417. Now, as you can see, I already answered my first question, which means, right, students, if I have the same volume of gas, I would, have the same moles of gas. But would they have the same mass? Now, the mass of gas is found by taking the molar mass times the number of moles. So in this case here, it would be 0.0417 times the molar mass, which is actually your 32. And leaving my answer in 3 significant figures, I will get 1.33, now the units is grams. Now, if, I now consider the case of CO2, I take the same number of moles here, and I times 44. I will get, 0.0417 times 32, I will get 1.83, and as you can see, grams. So, students, in this case here, that would pretty much means that I would have different, I would not have the same mass of gas if I have the same volume of gas. Now, students, before I finish this, I would like to advise you that when you are doing your calculation here, right, it is always better to use 1 more significant figures or 2 more. So in this case here, while I'm writing it here, you should, it should be preferably done in such a way that it should be in your calculator 0.04166667 times 32. And similarly for this case, you should press the calculator at least in this way to actually get a higher accuracy. And in this case here, also 0.04166667 times 44. So that, students, you will get a more accurate value. But you will always leave your answer, students, in 3SF. So there you have it, students. The first question is answered. If I have the same volume of gas, I would have the same moles of gas, okay, assuming they are all under the same temperature pressure. And however, I will have different, different mass. Now, let us, you can take a moment to look through this and to comprehend what's going on here. Now, let's consider another case. Okay, now students, I am going to give you another case. Now, the question is, does that mean that if I have the same, now, I'm going to tell you, I'm going to give you the same mass of gas. If I have the same mass of gas, my first question is, would I have the same volume? And also, will I have the same moles? Now, let's now consider this scenario now. Let me erase all this away. Now, in this case here, the mass of gas is given. This one we have to calculate again. Okay. The mass of gas now is given. So for the ease of calculation, what I'm going to do is I'm going to tell you I'm going to have 10 grams of oxygen and 10 grams of carbon dioxide. Now, with this in mind, let's first go on to see. With the mass given, to calculate number of moles, that will be 10 divided by 32. And this for carbon dioxide will be 10 divided by 44. Now, how do I get this? Well, because if you are given the mass, in order for me to calculate the number of moles, all I need to do is to take, mass, and divide it by the molar mass. So in this case, the mass is 10, the molar mass is 32, so 10 divided by 32. So if I were to take 10 divided by 32, that would be 0.3125. In 3SF, it will be 0.313 moles. To take 10 divided by 44, I would get 0.2272. In 3SF, it would be 0.227. And this, student, would be the number of moles. So as you can see, the number of moles when we have the same mass of gas for different gases is different. Will we have the same volume of gas? In this case here, remember, the volume of gas is found by taking the number of moles and multiply it by 24 moles, 24 dm cubed per mole. So, as a result of this one here becomes, remember, when I'm doing my calculation, I want to be more accurate, so what I will do is, I will actually do 0.3125 times 24. And this answer now becomes 7.5, 0.50 dm cubed in 3SF. Now, how about your carbon dioxide gas? Your carbon dioxide gas, is actually Okay, now it has becomes 0.227272 times 24, and now it becomes 5.45 dm cubed. Again, leaving my answer in 3SF. So, students, with this in mind, okay, you can clearly see that the volume, okay, with the same mass of gas is no longer the same. So, student, the conclusion, if I have the same mass of gas for different gases, I will obtain different moles of gas, and from there, okay, obtain different volume of gas. So, students, take some time to look through this. Pause if you need to. And with this in mind, students, you have understood how the relative molecular mass, the molar mass, okay, number of moles, and mass of gas, how they relate to volume of gas. Now, students, I do understand that this relationship, okay, and manipulation is difficult. So I want you to keep a lookout for another video that I'll make, that I'll present how to very easily, okay, obtain what formula to use in a diagrammatic form. So do wait in anticipation for the next video I am going to create. Thank you.